I haven't prepared anything. I would do so. The thing is, back in the days, I was a Java developer, like really back in the days. And then at some point, I became an Objective-C developer. Yes, I know this is. I'm trying to set up the scene for some interesting conversation here. At some point, I went to the dark side and started doing iOS development.
Yes.
And I've been doing that recently, most recently Python actually. But what you're really working with is absolutely new to me. So I decided, instead of preparing anything, why not just go along and ask stupid questions and
excellent. We shall try not to give stupid answers
and see where it ends. Yeah. It might be that I leave the room
a convert. We will bring you into the light.
Yes.
I mean, my laptop's over there. We can just start coding, you know.
Yeah. Maybe we should do that.
So all this talking, you know, talking is not for techies,
no talk, just code. Yeah. We tried that as a theme at the conference a couple of years ago. We had a room which we called No Slides, Just Code.
Yeah. No, well, I have this rule. I call it live coding summons the migraine fairy, because everybody says, when you teach, why don't you just go and just go in and live code everything?
Yeah.
And I said, because I've been traveling for 16 hours and I've eaten something that disagrees with me and I've got a migraine, you know, and I've been doing this for 20 years, 4 days a week, you know, so you can't always live code. You live code as much as you can, you know, whenever you're teaching, but at the end of the day, if you value your sanity, there has to be some kind of a limit to it, you know. So we like to say, write copious slides and then try never to use them, you know. But if you're having a really bad day, you know, then the slides are there as the fallback.
I think it's like the third rule of Hollywood, you know, don't work with kids, animals, and live code.
Yeah, exactly. Yes.
Yeah, there are probably a few people on the planet who are smart enough to just walk into the room and make it up as they go. But, you know, sadly, I'm not one of them. Yeah. Are you? Yeah, he is.
Yeah, so we have one of them here. I'm honored. Yeah. What is your background, actually? I'm just trying to find a clue where I can sit in here.
Oh, so, now you're asking. Eamon, do you want to start?
The story of your life.
Yeah. So, well, I've been coding since I was like very little. We had an Amstrad 464 with 64K.
I need to interrupt you already now. So the party last night.
Yeah, no, I was snapping photos of all. We did. I mean, I think I went from an Amstrad 464, and then the next machine we owned was like a PC with 2 megabytes of RAM. So I never had like any consoles or anything growing up. My friends had them, and I would like make excuses to go to their houses and stuff. But I love all that retro stuff. But no, we had a Amstrad 464 with a tape deck, and you know, it was like what Woz was talking about. You know, waiting for your program to load and all this sort of stuff.
Yeah, I know, but because back then Amstrad was kind of the other world. There was the Commodore world and the Amstrad.
Yeah.
Maybe
Spectrum.
Maybe the Sinclair.
Yeah,
too,
we have a Spectrum framed in the office.
Yeah.
It's like there's a lot of art and our CEO, he loves art, and there's some nice art scattered around the office, but my favorite is the Spectrum, even though it was the arch nemesis of the Amstrad.
Yeah.
But so, we had the tape deck, and you could load a program and it would run for like 10 minutes making this high-pitched squealing noise, and then your program would run and you would see it, and it was amazing.
Yes.
And it was all started by just like typing in from the manual. So just like blindly typing, and there was like magazines, and they had programs which would run games. You could write your own games, and at the start it was just like by rote, just copying.
And we both had the same experience, because you're downstairs eating your tea and you're listening to the game loading upstairs, and it's screw, damn it, you know, back in a minute, Mum, you're upstairs.
Yeah, I know. In the Commodore world, it was not just the sound, but a pattern on the screen too.
Oh yes,
Some lines, and you could just see if they got out of sync, you know.
Yeah.
That's a syntax error now.
Yeah. But there was like reams in these magazines. There was reams and reams of data sections, which were just hexadecimal.
Sometimes,
just typing those in was horrendous, and you'd make like one mistake and the program would crash. But I always just loved tech, and from that then to understanding what the programs did, and then through school competitions, and then my professional career has been started off mainly around like C++ and like close to the metal and telecoms and that sort of thing, and then migrating more into like desktop applications and moving into things like C#. And now we do everything, Angular apps and React apps and mobile apps and everything, all
Cool.
the platforms.
And I'm the complete opposite. So I started out in the same space. So whenever I was about 12, I got a Spectrum 48K, and I plugged it in, and it made multicolored blocks flash on the screen on Christmas Day and wouldn't do anything else. And I'll always remember my father saying, "Is this what it's supposed to do, son?" And me going, "I don't know." So it was broken, and we got a new one. And then I started programming, and the first program I typed in was Space Invaders, from a book in the library. And I finished typing it in at 4 a.m. very, very quietly, so my parents wouldn't know I was up. And
Well,
then,
it was quietly on the Spectrum because of the
the rubber keys.
rubber
Yeah,
keyboard.
real developers use
Yeah.
rubber keys.
Yes,
The
exactly,
Amstrad
yeah.
was solid. There was you knew you were pressing keys.
Yeah. But then I got Space Invaders typed in, and I went to play Space Invaders, and then it said syntax error at line 4, and I went, "What's a syntax error?" And that's where it all started. So I taught myself to program games and so on the Spectrum 48K. But then I got obsessed by the social sciences, and I wanted to be a criminal profiler, forensic psychology. So my first degree was in philosophy and psychology, and I specialized in social psychology and how people make decisions in groups. And at the time, what was called human-computer interaction and computer-mediated communication, which was all new at the time, which was how when people went to online bulletin boards, how that changed their patterns of discussion and how they became quicker to anger, and it was easier to misunderstand things and so on. So I did that, did a master's degree in criminology, and then went out to become a forensic profiler, only to discover that there were only 3 open jobs in the UK, and all of them
Well,
were
you
taken.
only needed one.
Yeah, so I starved, and then I came back. I was studying in England at the time, so I came back to Ireland, and I looked around for jobs, and I said, "People are getting paid to program? People are getting paid to program?" And I did a master's in IT, mainly to give myself a year to teach myself things. And then I got a job as a junior developer, and everything just went on from there. So I worked as a developer for 5 or 6 years, and I enjoyed it. But I was kind of casting around and trying to find some way to use my background in psychology, a little bit more, play to your strengths. So the opportunity came up to become a professional trainer, work for an IT training company. So I thought, what the hell, I'll give it a go. I'll probably only last 3 weeks. And that was about 15 years ago. So I started out teaching C++ to C people, then Java to C++ people, then C# to Java people, and then everything to everybody. Because as you know, our industry can't make up its mind. And for the last 3 or 4 years, we've been specializing in Kotlin.
If you had the chance to go back in time and freeze time at any point,
Yes.
what would you do? Where would you stop?
What about my life would I change? Or
No, not really. Just that's what I was doing around that time. Back in the Amstrad days, or would I just freeze around the C++ days? Or
No, I mean, I had a lot of nostalgia for my C++ days when I started moving into like the higher level languages and all like managed languages like C# and the like. And I was like, oh, I remember the C++ days when you had to know all the bits and the bytes and you had to know where the addresses were. And then I was teaching a clean code course, and it was using C++ 99, was like TR1. And I was like converting some examples and saying, okay, this is how you would write clean code. And I was just finding it so difficult. And C++, 17 and 19 have improved things, but I had this nostalgia that then when I went back, I was like, oh no, that's horrible. I understand why I moved away from it.
I think you always remember the good parts more than the bad parts. And the C++, I always remember like the intellectual struggle, and I enjoyed the way it took real effort to understand the language, and reading Scott Meyer's book about a dozen times, and then, finally understanding something and really enjoying that. But at the end of the day, I wasn't writing a lot of production code, So there are certain things about every period that you enjoy, but I don't think there's ever like a golden age of coding that we really want to go back to. I think, development has never been as good as it is right now.
So I wouldn't want to freeze time. I'd want to keep going because new things are coming out all the time. And when I look back at that older code, I can be more expressive now. I can describe the problems more effectively with modern languages. Things like Kotlin, they allow me to express myself in code in a much more elegant way, in a much simpler way. So then I can concentrate more on the customer's issues rather than, okay, I understand what I need to do. How do I do the translation? The translation is simpler. So I'm just waiting for, okay, what else is coming tomorrow? So I want to see tomorrow. I don't want to freeze any earlier time.
And I think one of the best things that's happened in terms of Agile is the fact that, we now let junior developers talk to customers. I remember back in the day when there was like 3 layers between you and the customer, and all you had was a use case report, which might have been very good, it might have been very bad, but that was, your only source of truth. So you're a medieval monk just looking at these 2 sentences, trying to work out the different permutations of what they might mean and so on. So don't want to go back to that. Yeah.
So Kotlin is your favorite programming language right now?
I would say so. Okay, you probably yes.
Is that favorite language? If somebody gave me a team of developers tomorrow, and said you have to write an enterprise app, it would instantly be Kotlin. If you mean, my favorite programming language is XSLT. So I love just hacking around in XSLT.
Oh, you're rare species.
Yes. So in fact, my friends will tell you any programming language I say I like, it's kind of like the death touch. They immediately say that language is dead, But for Kotlin is absolutely the best language if you have a team of developers of varying skill sets and you want to get something quality out the door as soon as possible, So it's in that sweet spot for modern development, and that should, that shouldn't be surprising because that's what it was designed for, So.
But why? So other languages develop too.
So we see a lot of similarities between like modern languages. So if you look at snippets of something like say like Swift or snippets of Kotlin or even C#, there's a lot of similarities in the features and John Skeet's doing a talk at the moment about nullable types in C#. So C# 8 is getting this ability to define types as nullable and non-nullable, and this is something that Kotlin has already. So we do see, the languages leapfrogging each other and they have their place. So
And that's the thing, a lot of people who are new to the industry, they kind of freak out a little bit and they say, look, I'm scared by the polyglot programming, by the number of languages. I just barely feel that I've learned Java or C#, but should I be learning Swift? Should I be learning Kotlin or Scala or Erlang or whatever it happens to be? And the thing that we teach is that all of these languages are kind of converging, on the same space. So if you were to draw a graph of all the different language features and so on, there's kind of a hot spot that everybody's converging on, and Kotlin, because it's a more modern, more recently designed language, it pretty much started off in that sweet spot, and other languages are moving into it, so C# is adding features, Scala is taking off features and so on, everybody's heading towards the same area, so you could have the same experience that you have in Kotlin by saying, do Scala but don't use all of that stuff, okay, or do C# but use this newer stuff and so on, but Kotlin is just there already.
But so I always look for the features that allow me to be expressive. So there's like a series of things that I'm now spoilt with. I've used in other languages, and then when I go to a language that doesn't have them, I get frustrated. I'm like, okay, well, I can't express myself as clearly. So things like extension methods and null safety, smart casting by the compiler. I obviously want a statically typed system. I prefer that because it gives me autocomplete and refactoring. And I'm now in a world where I need good tooling so I can keep my code clean continuously instead of going, okay, it could be better, but I don't have time. Now I do a shortcut and the code is cleaned up and I can say, yeah, that's going to be more maintainable. That's more expressive bit of code. So for me, there's a certain set of features that I really like. And on the JVM, the most prevalent language is obviously Java. It's the Java virtual machine. I always found Java more frustrating, and there's historical reasons for this, and some of this is it's like designed by committee and things move a little bit slower. And sometimes when you have someone who's a little bit more control and can just say, like a benevolent dictator can say, this is the way it's going to be, things can move a little bit quicker. And for me in the JVM, I love C# and I like developing in .NET, and if there's certain organizations are Microsoft houses, that's the stack they will use. But the JVM, there's more stuff written on it. The ecosystem is really good. The community is really good. The libraries and solutions that are out there that you can leverage are really, really good. The big problem was Java. So for me, I don't like reinventing the wheel. I don't like the fact that there's a lot of churn in our industry, especially we see that in front-end development. But for me, there was a problem on the JVM, and Kotlin is the solution. Kotlin allows me to be as expressive as I am, say, on the .NET stack in the JVM. And they've done really good engineering decisions, like the interop is like a primary goal. Yep. So all of that legacy Java code that I have, all of that knowledge and the APIs that I know, I can just consume readily. So for me, we found, like in the space of a week, you are super productive in Kotlin. It's not like, okay, I have to change my mental models and it's a real paradigm shift. It's seamless. But now it's like, okay, well, that's neater.
That's why as a company we made a bet in Kotlin about 4 years ago. I mean, we don't get royalties or anything out of it. We were just doing a lot of work on the JVM. In particular, we just won tenders to do several major large Android applications. And the guys in the development team, they'd been on Xamarin for a long time. They'd been doing Objective-C, they'd been doing Swift and so on. And they basically came to management and went, we don't want to go back to Java. And so some of the guys in the training team had been playing around with Kotlin, and we were saying, look, this seems really nice, we should give it a go. So they went off and wrote some prototype, Android applications in Kotlin, and then they came back and said, look, on Android anyway, brilliant. We want this, okay? We don't want Java, we want Kotlin for the next project. And it worked out incredibly well on the development side of the business, and that's why, I then turned around to JetBrains and said, hey, would you like a classroom-based training course? And they said, yeah, if you're mad enough to write it, So I went out and wrote it, and they came over and accredited it and so on, So the reason why we spend so much time doing Kotlin these days is simply because as a company, we've placed a bet on it because we think it's the future, and we evaluated the others. I am a huge Scala fan, as he'll tell you, but the guys in the office, they just found Scala overkill, so they did the online training courses, they got a pile of the certifications and so on. They did a really deep dive into the language and said, look, there's a lot to like in here, but it's too complicated for what we're doing at the minute. We can make more progress with something that's simpler.
I have one last thing that you mentioned something about upcast and downcast and null pointers or references or whatever we call it. I have an illusion that I understand this because I am the same generation in this field as you are. So back in the days, we need to know about memory, registers and everything. I also have a feeling that we don't educate young people from that level and up.
Well,
is that something we should?
Yes and no. I mean, this is something that gets hotly debated, and as an educator, this worries me. So the standard question that people ask is, should all developers learn C? And
or at least text code.
Oh and for a while I believed in this, and I said, yes, all developers should learn C because this will give you like a real understanding of memory management. But then I read a tweet that turned me around completely, and I forget the author of the tweet. I apologize, but. They said, yes, C programming gives you an understanding of hardware as it was in the mid-1970s. Okay, so
but it still gives me a feeling about why I should avoid doing this or that rather than just that I should.
I think there's like an awareness that you have to have, but there's so much abstraction between what you're writing in your source code and what actually runs on the metal now. You have the optimization of the initial compilation step.
Yep.
You have the just-in-time compilation step. You have the operating system. You have all of the different layers within hardware, in the processor, in the floating point units, in the different levels of cache. We find now that, for example, if you look at the complexity of algorithms, we find that some algorithms which are less efficient on paper are more efficient when we do like simple linear searches and things like this because of the hardware, the hardware sympathies there with cache lines and things like that. So I'm a little, I'm like you. I think that we should teach some of the fundamentals. We should understand, about the architecture, about operating systems, about some of these things. But
The question...
Whenever I'm writing code, my first thought is always towards the readability of the code and how easy is this going to be maintained, and does this express my ideas? Yeah. Performance is always the second thought. Now, if I have two solutions and they're equally readable, and I have a hunch that this one's going to be more performant, okay, I'll go this way. But normally, it's what I'm focused on is readability. If performance is a concern, then what I will do is I will write some performance tests and I will measure, because that's the only way to do it.
Yeah.
So the knowledge from understanding the architecture doesn't have as big an impact as you might think.
I mean, I think you're completely right that we need to give developers kind of underlying understanding of what's really there. But as Eamon says, there's just so much. I mean, you could talk for an entire week, you know, and we know performance consultants who could just talk to you for an entire week about nothing but the dynamic optimizations done within the JVM as it's looking at your code and profiling it in the fly and so on. And then, as you say, with the cache lines and all the stuff that's in modern hardware, and then what the compiler's doing and so on, you know. And we know performance experts who teach courses where they show you two versions of the same code, you know, and with my 1980s understanding of hardware, I would be willing to bet all the money in my wallet that the one on the right, you know, would run faster, but it's actually the one on the left, you know. So it's a little bit of knowledge is a dangerous thing. So you're at the moment, if you're a developer writing code, you're sitting atop a huge tower of optimizations, and the question is, you know, what understanding do we need to give junior developers or all developers, you know, without overloading them? And that's a very open question at the minute, you know. So, we can't write code completely ignoring performance. Yeah. On the other hand, we can't all write code that like we're writing a stock exchange or we're NASA or something like this. You know, we have to find a kind of sweet spot between the two for most people most of the time.
Brilliant. Let's keep it here.
Yeah.
We could go on forever, I think.
Yeah. Talking is what we do.
Yes. And well done.
Yeah. No problem.
Thanks a lot.